Hello, 7th graders, and welcome to Lesson 2-3, which is on simplifying algebraic expressions. In tonight's lesson, you have two main objectives. First, you will be able to identify parts of an algebraic expression, and you will be able to simplify expressions. Alright, so we're going to go ahead and start right away with the warm-up, which talks about simplifying each expression. And I take a look at all these, and I see a number on the outside. For number 1, for example, 5 times the sum b plus 4. Well, you can't do order of operations here because you can't add together b plus 4. So this must be on the last lesson on the distributive property. And I'm going to go ahead and let you do these 4 problems. And then when you're all done, come back and check your answers. Go ahead and pause me now. All right, let's see if we have our answer right. Now, the main idea with distributive property is the number on the outside multiplied by every number on the inside. So for number 1, we do 5 times b, then we do 5 times 4. So 5 times b plus, because there's that addition sign, 5 times 4. And I get 5 times b is just 5b, and then 5 times 4 is 20. That'd be my answer for 1. Number 2, same idea. First, I multiply negative 3 times 2x, then by 5. Well, I know negative 3 times 2 is negative 6. So negative 3 times 2x would be a negative 6x. Then I write my plus sign. Negative 3 times 5 is negative 15. So what I end up with is negative 6x plus a negative 15. Now, I'm going to tell you this. You normally don't want 2 operations in a row like this. We have a plus and a minus. So what ends up happening is because this 15 is negative, you can just write it as negative 6x minus 15. This is a more appropriate way to write it, excuse me. All right, so then we go to 3. 4 times negative 8 is negative 32. I write my minus because that's what I see. Well, 4 times 3 is 12, so 4 times 3 cubed would be 12 cubed. That'd be my answer. And of course, we have number 4, negative 6 times 2b minus negative 6 times 7. Well, negative 6 times 2 is negative 12. So negative 6 times 2b is negative 12b. Minus, well, negative 6 times 7 is negative 42. Now, again, this is one of those times we end up with 2 operations in a row. All right? This is a time where, well, this is a subtraction problem, so you could add the opposite. So you'd leave the negative 12b alone, but plus the opposite of negative 42 is a positive 42. Or again, if you just remember the quick idea of 2 negatives in a row, make a positive, same idea. All right, so that's your warm-up. Now we're going to go ahead and look at the first objective, which is on identifying parts of an algebraic expression. And we talked about algebraic expressions back in lesson 1-1. So this is all coming back to us now. And we're looking today at specific parts. And there are 4 key terms. The first one is, in fact, the term. This is a number or the product of a number and variables. All right, so this is basically the term or the algebraic expression you're given. All right, then we have the constant, which I'm going to underline in red, which is a term with no variables. So really, when we talk about a constant, it's just numbers, like 2, 4, 13, negative 37. Any number is just a constant. Then we have like terms, which are identical variables. So for example, if they have the same variable, they're considered like terms. 7a and 3a are considered like terms. However, if I had 7a and then 3a squared, they are not identical because one is a and one is a squared. So the variable has to be the same power. It has to be a or b or ab together, or so on. And then finally, we have coefficient, which is a number that multiplies a variable. So if I go back to an example of, let's say, 5c, so 5 times c. The number that is with this variable, in this case, the 5, is considered the coefficient. So it's a number that is with that variable. All right, so I just gave you 4 terms. And down at the bottom, you'll notice that there is an algebraic expression. I have 7a plus 4a plus 3b plus 2. Your job is to figure out which one of these terms goes here. So where's the example of the constant? And write that down on that line. Where's the example of like terms, the coefficient in the term itself? So for example, to get you started, this red bracket is basically going to everything. It means it's all included. So 7a, 4a, 3b, and 2. Well, all those are considered terms. All right? You have 3 more to fill in. Why don't you pause me and get started? Pause me now. All right, let's check your work. I'm going to go to that blue line, so I'm going to go counterclockwise this time. And I see that this blue one is going to 7, the 4, and the 3, I believe. Well, the only thing they have in common, those 3 terms, are that they have variables. So if I take a look, I'm going to assume this is the one that talks about coefficients, because these are the only numbers with coefficients. All right, and then we have, in black, well, this one is going to 7a plus 4a. Well, the only thing they have in common is they both have the 8. But because they both only have the 8, they are like terms. And apparently my smartboard stopped working on me for a second, so I'll rewrite that, coefficients. And then finally we have that green bar that just goes to that 2. Well, number 2, it doesn't have any variables or anything like that, so that would be considered the constant. It's just a number. There we go. Now, here's some practice problems for us. Now we know what coefficient means, like terms and constants. Now, in this problem, in this expression, they want us to name the coefficients, the like terms, and the constants. In 7 times x plus y minus 2 times x minus 7. So we're going to go ahead and get started. And do this along with me, please. Now again, the coefficients, if you forgot what that means, it's just a number in front of those variables. So for example, we have 7 times x. Well, that number with the x is 7. All right, then we go to the y. Well, that's a variable, so there is a number in front, even though they don't show it. Whenever they don't show it, again, that means there's a 1. When they have y, it really means 1 times y. If you go back to the identity property, again, what number times itself gives you the other number, well, that would be 1. All right? And then let's see, we have negative 2 times x, or minus 2x. Again, you put in that negative 2 or minus 2. Because it's subtracting it, that subtraction sign goes with it. Just like the 7 is positive and this 1 is positive. All right? Then we go to like terms. So we're going to look for those variables that have the identical variables. And let's see, I see 2 numbers that have exact same variables. And that would be 7x and this minus 2x. Again, I put the sign with it. So minus 2x or negative 2x. And then of course we have the constant, and that's just a number, no variable, and I see that as, well, minus 7. There we go. That would be what you have for number 1. Now number 2, that's your job to do. Name the coefficients, the like terms, and the constants in negative 4 times x. Now, because this is a short expression, you might not have some of these things. But go ahead and go through it. All right, and just do your best, and when you're all done, come back and check your answer. Go ahead now. All right, in this problem, coefficients. Well, we do have a coefficient. That's a number being multiplied by x, and that is negative 4. Like terms, well, I'll be honest with you. In order to have like terms, we need more than 1 term. So there is none. All right, and then a constant, if there's a number without any variable, and there's not. So there is no constant either. However, if we had negative 4x plus 2, then our constant would be 2. Or constant would be plus 2. But there is none, so it's just no constant. All right. Now we're going to go into objective 2. And what you see here are some different shapes. We have some squares, we have some circles, some triangles, and so on. Match the shapes that go together. Now I know this seems like a very young children's problem, and I'm pretty sure you don't even have this on your notes. All right, so don't worry about this so much. But I know you know that circles all go together, and squares all go together. And of course, the triangles all go together. You learned this back in kindergarten, or maybe even preschool. That's not new. But we can use this idea in algebra. All right? When we know something goes together, that means they're alike. So I'm going to switch this up. I am going to name each square x. So if I were to ask you how many x's I have, you would say, well, you have an x plus another x plus another, giving me 4 times x, or 4x. All right? I could do the same with these circles. I could name them y. And I would have, well, y plus y plus y plus y plus 5, or y, I'd have 5y, or 5 times y. And again, I could do the same with the triangles. I could name them a's. A. And I have 1, 2, 3, 4, 5, 6. 6 a's are 6 times a. Now, you know that they have to be alike in order to go together. Otherwise, you can't add them. I can't put together one of these triangles and then take one of these circles and say, I have, 2 triangles squared. That makes no sense. I'd either have 2 triangles or I'd have 2 circles. So they have to be similar. Keep this in mind for the next problem. And I'm going to start modeling this for you. And they tell us simplify 9 plus 4 times f plus 3 plus 2f. Now, I already drew this out for you. All right? These little yellow boxes are all plus 1s. And I have 9 of them for this 9. All right? Then I have 4f. Well, each one of these 3 rectangles are an f. So 1, 2, 3, 4. 4f. Then again, I have 3 of these yellow little ones for plus 3, and then 2 more f's. All right? So again, the ones that are the same you can put together. So I could move, maybe not. All right, I'm going to erase all that writing. All right, I can move the ones that are alike together. So there we go, and then I can move these f's together as well. So if I were to figure out how much I have, well, I have 1, 2, 3, 4, 5, 6. I have 6f, so 6 times f. And then, well, how many little yellows do I have? 1, 2, 3, 4, 5, 6, 9, 10, 11, 12. I have 12 positives. So my answer here is 6f plus 12. All right, that's one way you can do it. Or another way to do it is basically just circle the numbers in the original problem that are the same. So I have a plus 4f that I'm going to circle. And then, a plus 2f, because they are like terms. They both have that f. All right? And again, you notice that I circled the plus sign with each one, because that'll tell me that, I add them together. Or if there's a minus sign, it's like, I have to subtract them. And then I'm also going to do something with these. I'm going to put the constants in triangles. That way I know those go together. All right, it was just like matching activity I just did. Now I add my red circles. I have 4f, and then I add 2 more f's. Well, that gives me 6f. Now, I have 9 plus 3, my 3 triangles. 9 plus 3 is 12. There we go. So either way, I got the same answer. I could do a model, or I could just circle the ones that are like and go with it that way. Now, this next problem, you get to choose how you want to do it. I have simplified 5y plus a y. All right? Again, you can make a model if you prefer, or you can circle the ones that go together. I want you to solve this problem, and when you're done, check your answer. Go ahead and do that now. All right, I'm going to go ahead and choose to circle the ones that are alike. So I have a 5y plus another y. Now again, whenever I see a y just on its own, there is a number in front of it. And I want to make sure I write it in so I don't forget. All right, there's that 1y, meaning there is 1 y total. So if I have 5y and I add another y, well, that's 6y. If you chose to do a model, maybe you made long rectangles. I have 5 y's. Each one of those are a y. And I added 1 more y to it, and I have 6y. So either way, we should have 6y. All right, this is our next example, and it says evaluate 4 times g plus 9 plus 3 times g if g is equal to 5. Now, we solved these problems before when we were talking about evaluating expressions and then using order of operations to solve. And I'll show you how we did that in a moment. However, we could use that skill we just learned about putting together like terms to make this an easier problem for us to solve. So go ahead and find the two terms that are like terms here. So they have the same variable, and circle them with the sign in front. All right? So if you just did this, or if you do it along with me, there's this 4g, and then there's this plus a 3g. Both of them have g's, so they're like terms. So if I have 4g and I add 3g to it, I have 7g, and now I'm just rewriting that plus 9, because those are not like terms, so I can't put them together. So this is what I have now, 7 times g plus 9. So now I'm going to stick this 5 in for the y. And I have 7 times 5 plus 9. Well, order of operations, I multiply first. 7 times 5 is 35, plus 9, well, that is 44. That's my answer. Now, I'm going to show you the way we did it before. So we did 4 times 5 plus 9 plus 3 times 5. Order of operations, you multiply from left to right, I get 20 plus 9 plus 3 times 5. Well, I still have to multiply before I add. So 20 plus 9 plus 15. 20 plus 9 is 29 plus 15 is 44. So we get the same answer, but there's a lot less work with the one in green in comparison to the one in blue. So again, you can use those skills we just learned to make the problems a little bit quicker for you. All right, and here we go. We are at the end of the lesson, and this is basically the check you're learning. All right, so what I want you to do is do 1 and 3 only. For number 1, you need to name the coefficients, the like terms, and the constants. And then number 3, simplify the expression. Okay, so go ahead and pause me now and do those. All right, so let's check number 1. Coefficients. Again, are those numbers in front of the variable, and I see a 4 and then -2. For like terms, I'm looking for those variables with the same those same terms, I should say, with the same variables. And I have 4x, and that minus or -2x. Then I have constants, just regular numbers, and I see that plus 3, or just 3. That's what you should have had for 1. If you didn't get a piece of this right, I encourage you to do number 2, because it's just extra practice. All right, and if you want to, you can ask me questions tomorrow on it. Now for number 3, this one has a little bit of a distributive property in it, because it has 3 times a plus c minus 1. So first, you need to actually use the distributive property in order to solve. So 3 times a, or 1a, is 3a. 3 times 1c is 3c. And then 3 times 1, there's that minus sign, so that's a -3. And now I'm just rewriting with that -2c. So that's what it is expanded when I use the distributive property. Now I need to look for those like terms, the ones with the same variable. And if you do that, there's this plus 3c and a -2c. See, this is why it's important to put that sign out in front. Otherwise, when I do this, I have 3a. Now, the c's. I have 3 c's, and then I want to take away 2 c's. Well, 3 minus 2 is 1. So you're left with 1 c, or just c, and then that -3. And again, the rest of it, this is as far as you can go, because you cannot combine the 3a and the 1c because they aren't identical. They don't have the same variables. All right? And I think this is where we're going to stop today. And again, if you got 3 wrong, try number 4. See if you can get that. And you can ask me tomorrow morning. But this is the end of your lesson. I will see you tomorrow morning. Have a good night.